Long before atomic clocks, ancient civilizations looked up to track time. They relied on three celestial bodies: the sun, the earth, and the moon. Physical reality dictates the simplest units of our lives. The Earth's rotation on its axis creates a day, the phases of the moon create a month, and the Earth's full orbit around the sun dictates a year. This animated diagram illustrates a major astronomical problem. These three cosmic periods are not clean integer multiples of each other. When you put them together, their gears grind. Nature provided three independent clocks that simply refuse to synchronize, leaving early astronomers with a massive mathematical puzzle. Different cultures attempted to bypass the mismatch by ignoring one clock entirely. The Gregorian calendar is strictly solar, skipping over the exact phases of the moon. The Islamic calendar is strictly lunar, ignoring the sun. Following a purely lunar cycle comes with a strict mathematical consequence. Every 12 months, the lunar calendar falls about 11 days behind the physical solar year. Over centuries, that gap creates severe cultural drift. If Indian festivals relied solely on this tracking, winter holidays would eventually land in the blazing summer. Within 11,000 years, harvest festivals like Pongal would drift completely out of the agricultural seasons they celebrate. A drifting calendar detaches a society from the soil. For an agrarian civilization dependent on seasonal rains and crop yields, losing track of the solar year is a threat to survival. To understand how these systems shear apart, we have to look at the hard astronomical measurements. A solar year is exactly 365.2422 days long. This vector model diagrams the lunar synodic month, the time it takes for the moon to cycle entirely through its phases. That period is exactly 29.531 days. Because the Earth continues to move along its own orbit around the sun, the moon has to travel an extra 2.2 days just to catch up and align perfectly to form a full moon. When you multiply that 29.531-day cycle by 12, a standard lunar year equals roughly 354 days. Subtracting that 354-day lunar year from the 365-day solar year leaves a strict deficit of nearly 11 days every single year. This diagram shows the physical offset. That 11-day deficit is a cumulative glitch, pushing the lunar and solar tracking systems further apart with each passing cycle. Ancient Indian astronomers refused to abandon either celestial body. Instead, they cleverly developed a lunisolar system that accounts for both. This stacking bar chart visualizes their method. They deliberately let the 11-day gap accumulate year over year. They tracked it to the exact mathematical breaking point. After approximately 32.5 months, that accumulated gap equals exactly 33 days. At this interval, they insert a 13th intercalary month into the calendar, known as Adhik Mas. By adding one full lunar month roughly every 2.5 years, they apply a self-correcting mathematical patch. The lunar calendar snaps perfectly back into alignment with the solar year. The result of Adhik Mas is a calendar balancing the spiritual phases of the moon while remaining firmly locked to the physical seasons of the sun. But keeping these clocks aligned requires constant observation because the solar system is not static. The moon exerts a massive gravitational pull on our oceans. That pull creates tidal friction. The moving oceans act like a subtle brake on the Earth's rotation, lengthening our days by tiny fractions of a second over millions of years. This newspaper clipping shows how modern timekeepers handle the deceleration. We occasionally have to insert leap seconds into our atomic clocks to keep up with the slowing Earth. Thousands of years ago, Indian astronomers lacked atomic clocks, yet they observed these shifting cosmic mechanics and built massive stone instruments to track them. They engineered a self-correcting temporal system that prevents seasonal drift, permanently syncing human civilization with the orbital mechanics of our solar system. Keep watching the Sutreya channel for more such information and subscribe the channel for future uploads.